Hey, good afternoon, ladies and gentlemen. It is 3:45. You know what time it is? Yeah, you do. It's time to do some math. Let's get to it. We're looking at the homework for tonight. You were asked to do first page, back page, and number one on the staying sharp. So let's get to her. So you have this math club selling rolls of wrapping paper and ribbon as a fundraiser. They must spend less than $600 to purchase the fundraiser items. Each roll of wrapping paper costs $2. Each ribbon costs $3. So this is pretty important information. So I'm going to highlight it just for my own good. So I have to keep researching it every time. So the question is it possible to buy 250 rolls of wrapping paper and meet the conditions above? Why or why not? Well, what we have to do is figure out what the condition even is. And in this case, the condition is $600 is our limit, which means we can spend anywhere as long as it is less than or equal to $600. That is our no. Let me take that back. It's not less or equal to. It's just simply less than. So I'm not actually allowed to spend $600. I have to spend less than $600. Important distinction. So let's find out how much 250 rolls of wrapping paper would even cost. I'm buying 250 rolls of wrapping paper. Wrapping paper costs $2 each. We're looking at a multiplication problem. That's $500, which is under budget. So the answer ultimately is yes. Yes, I can. Is it possible to buy 250 rolls of ribbon and meet the condition above? Why or why not? Well, let's check it out. 250 rolls of ribbon. Each ribbon costs $3. Now we're looking at $750. So the obvious answer here is no. I'm not going to write it out, but why is it no? Because, well, the condition is less than or equal to 600. This will require me to spend $750. Not good. So what you're looking here is just a kind of a separation of this problem. Can you just simply recognize that to find this whole cost, you are going to have to do a multiplication problem to 250? Hopefully you have. Is it possible to buy a combination of 100 rolls of wrapping paper and a whole 100 rolls of ribbon and meet the conditions above? Well, let's take a look at it. If I buy 100 rolls of wrapping paper, so 100W, and I add that to 100 rolls of ribbon, so 100 times R, that whole thing has got to be less than 600. So this is really ultimately what I'm checking. If I take 100 times $2 each and add to 100, that costs $3 each, so that's the wrapping paper, that's the ribbon, it's just less than $600 as a whole. Well, this piece alone is 200, that's going to be 300. So the question is 200 plus 300 less than 600? Well, of course it is. 500 is less than 600, so the answer ultimately is yes. Yes, I can. Okay. So just some algebraic working out. Again, central idea, 600 is our limit. Let's go to page 2. Find 3 other combinations of wrapping paper ribbon that will meet the conditions above. Again, I know this is kind of a weird way to look at it, but this is something we need to get used to, expressing our ideas in the form of like a relationship equation, in this case inequality. So we have to know some number here. I'm going to call it W at $2 each, plus a certain amount of R's, ribbons, at $3 each. That's going to be less than 600. And we're just asked to find 3 combinations that work. Well, how many conditions could there possibly be? My guess is a ton. Like, you guys came to the conclusion today that for that problem about the helicopter, that there's going to be darn near an infinite number of solutions. Well, I agree. I think there will be. So coming with solutions here may be futile. We could totally do it. What I'm going to kind of do is think about, like, what's the most I can buy. I'm going to think about my limits. So since I can kind of find 3 combinations, I'm wondering if I'm only buying wrapping paper, how much could I really buy? At $2 each, seems like I should be able to buy 300, but I can't buy 300 because I had to say 100 my $600 budget, and 300 rolls at $2 each would be 600. So I know that I can buy 299 rolls of wrapping paper, which would leave me $2 left over, which would give me no money for ribbons. I'm going to look at the other end, the other spectrum. What if I were only to buy ribbons? Well, 200 ribbons would be $600, so 199 ribbons would be 1. So buy one back, which would allow me to really buy 1 wrapping paper, because 199 at $3, take 1 away. That'll leave enough for wrapping paper. And then just because I'm feeling crazy, it never said to buy anything at all. So I'm pretty sure I could buy 0 wrapping papers and 0 ribbons. Now to put this all on the grid, well, that's going to be kind of a monumental task, especially given the numbers I chose. But I kind of chose them on purpose that way. So let's go ahead and put our axes in. Womp. Womp. Okay, let's establish what goes on our axes. So I'm going to go ahead and graph, and just because I think I want to, wrapping paper here, ribbons here. So looking at the numbers, the smallest R I have to deal with is 0, biggest R is 199. So I think I'm going to count by 50s here. So that's 50, 100, 200, 300, 400. Okay. And looking at my W's, the biggest W I need to account for is that, so I'll count by the same. So 100, 200, 300, Okay. So to put these on the graph, they're not going to be perfect, so I'm just going to try to get as close as I can. Here's 0, 0, 199R, 1W, so 1W would be like right next to it, 199R would be just under 200. Okay. And then 299W, 0R, so 299W, 0R. Okay. So hopefully you're seeing something kind of like we did this today. I chose those numbers on purpose, guys. I'm not going to lie to you. I chose those numbers because I knew that today we talked about finding like the extremes, pushing the limits. And to me, these are the 3 most extreme points. What if I were just to buy one of something? What if I just to buy one of the other thing? And what if I bought nothing at all? That kind of sets my boundary. So I'm going to go ahead and push this problem a little bit more than what the book wants you to. I'm going to go ahead and shade in all the places I can find this answer. So if this is my limit, I claim my answer is anywhere that I'm shading. And these are all good combinations. Okay. So kind of an unusual problem, but a problem that makes some sense. We step back and think about it. There's a whole lot of combinations of wrapping paper and ribbons I could buy as long as I'm staying under the $600 barrier. And in this case, that is the $600 barrier. Okay. So anything underneath that line should work. Awesome. Let's get going. Okay, so we have this problem. A school board is investigating ways to hire staff for the summer school program. They can hire teachers and aides. There can be no more than 50 staff members altogether. A graph below represents the solution. So let's pick out some important information. I'm going to write it out here. So 50 staff total. Okay, and it's going to be comprised of teachers and aides. Okay. So this graph represents below. Now let's see if we can make some sense out of why this graph is shaded and what these pieces mean. Well, first of all, they said they could hire up to 50 staff members. So that means this point is pretty good. That means that's the case where I hired nobody. Let's look at this point right here. This is where it looks like they're only hiring teachers and no aides. So what number do you suppose is that right there? Like what can it max out at? Pause the video, think about it. Boom. Hope you guys came up with that right there. Boom, being 50 teachers. And no aides. Okay. Again, we're looking at the extreme. So the other extreme on the other end of the spectrum should be that situation reversed. So that point would be like 50 aides and no teachers. Okay, so between those 3 extremes, where you hire nothing, you hire all teachers, you hire aides, are all the possible combinations that work. Now, hopefully, an idea is creeping into your head that says, "Well, I can't take every point in here. Could I really hire 12 aides and 20.1 teachers?" Well, no, probably not. But that's a good thought to kind of adopt going forward into tomorrow. Okay, so, look at this question. I can already see it on the horizon. Look what they're about to ask us. Can you find 3 points in the graph and satisfy the conditions of the problem? Explains why it satisfies the conditions. Well, I just actually did find 3. 0 teachers, no aides. 50 aides, no teachers. This, of course, would be 0 teachers, 0 aides. Now, something to keep in mind that this is a possibility. It never said you had to hire anybody. It said you could hire up to 50 people. This one's okay because it never said you had to hire any aides. It just you're hiring 50 staff members. On reversal, never said you had to hire a teacher at all. You could have 50 aides and no teachers whatsoever. Okay? You could have 50 Mr. Grants and Mrs. Scotts and Mrs. Clinkies running around. 50 aides, no teachers. Okay? Of course, there's other points as well. Like if you go to the middle, just picking any point, like let's say this guy, that's fully explainable as well. This would be 8 aides, 28 teachers. Or this guy right here, 40 aides, 4 teachers. Okay? So every point is explainable. It makes sense in context of the problem. As long as the total doesn't exceed 50, we're good to go. And if you look at all these combinations, 50 plus 0, 50 plus 50 plus 0, 0 plus 0, 40 plus 4, 8 plus 28. Those are all still under 50 total staff members, so we are good. We'll scroll down. We'll see what they have in store for us next. Find 3 points on the graph that do not satisfy the conditions of the problem. Explain why they do not satisfy the conditions. All right, well, this should be easy. Let's go to purple. In other words, we had to find a combination of things that do exceed 50. Excuse me. So using what the conjectures were today, I'm going to pick a point right here. Well, that tells me I'm going to hire 44 aides and 44 teachers. Well, this is a no-go point. Why? Well, because 44 plus 44 is 88, guys. You can only hire 50. How about this point right there? 36 aides, 20 teachers. That's 56 total. That's no good either. So hopefully you guys are forming the schema in your head that if I want a solution, it's got to be in the shaded part. If I want a non-solution, it's got to be in the non-shaded part. I mean, just pick even a random one. What one that's like really close? How about the guy right there? We're looking at 8 and 44. 8 aides, 44 teachers. That makes 52. That's too many. So again, hopefully forming this really great idea in your head that solutions are where the graph is shaded. Question 3, what is different about the locations of the points listed in question 1 and question 2? Well, how many times can I say it? It looks like the answers are going to be where it's shaded, this part, and the non-answers are going to be where it's not shaded, this part. So again, it seems like the most important thing you can do is find the extreme boundaries, and that'll set your perimeter that's shaded in the area. You got your solutions. Let's talk about this one. Okay, staying sharp. Solve the following equation for P. Give your answer with supporting work. Oh, I love these. These look like how we started this whole thing, man. So let's check it out. I'm going to rewrite it big over here. 3 over 2 plus 5P is equal to 11 over 2. Now, here's what we're not going to do, guys. We are not going to lose our minds just because we see a fraction. We're going to deal with the fraction. We're going to be okay. So let's review. What does it mean to solve for a variable, to solve for P? Well, what this means, hopefully in your head, is that I need to get P all by itself. So in the end, I should see like P equals all this other stuff over here. And I don't even care what this other stuff over here is. I don't care if it's really, really dirty. I don't care. All I care about is on the left-hand side, I have P equals all by itself. Okay? So let's get to her. So step 1, we had to identify what's been done to P so I can undo it. Well, what's around P that I got to get rid of so P is by itself? I see a positive 3 over 2. I see a multiplied 5. Reverse order says I got to take care of the addition problem first. Now, this is addition, guys. I don't see a subtraction sign. Do you? A negative sign? I don't see one. It's addition. Therefore, to undo it, we're going to subtract. And, of course, the subtraction property of equality states if I do it to one side, bam, I'm doing it to the other as well. Break the equation. Let's solve. This was to cancel. 5P continues down because nothing was done to it yet. On the right-hand side, I have a problem I can support. 11 halves minus 3 halves. Well, if I have 11 halves and take away 3 of those halves, I should have 8 of those halves left. 8, 9, 10, 11 makes 8, 9, 10, 11 makes the total number of halves I started with. Now, of course, 8 over 2 is silly. I don't want to write it as 8 over 2. 8 divided by 2 is a findable number. So what I really have is 5P divided by 4. So we undo the addition, now let's undo the multiplication. It is multiplication. So in terms of what to do, well, I got to break that. Multiplication is killed by division, both sides because of the property of equality. Here cancels, leave me just with this P, 4 over 5. I'm going to leave this 4 over 5, but if you're getting really squirrely, I guess you can make it 0.8. Okay. Alright guys, so that does it for this video. This is homework 14.5. Tell your friends, tell your parents, anybody who wants to come in, learn some math, have them join, have them, this way they can help you with your work when you're outside of school. Hope you guys have a great day, great evening. Thank you for working hard on the homework, and I will see you tomorrow. Stop video.